So this is the chemical process lab. We're going to test different chemical processes to determine what might be used for a cold pack. We're going to calculate temperature changes that occur and make observations about how each chemical process might behave. To design a cold pack, you must determine what characteristics a process should have in order to be a solution. Think about the criteria needed for a usable cold pack. For example, the cold pack must get cold and it needs to do so quickly. We have several materials that we're going to use: ammonium chloride, baking soda. We have our 250 milliliter bigger sized beaker. We're going to use calcium chloride, a graduated cylinder for measuring out our water, some paper towels in case we make a mess, steel wool, a stir stick, thermometer, vinegar, and of course the water that we will measure out. So for step one, we're going to get the liquid component, which happens to be vinegar for our first one, and a solid component, which is the piece of steel wool. We're going to take 50 milliliters of the vinegar and we're going to pour it into our much bigger beaker. So here's our bigger beaker. This is my vinegar, and I'm going to pour in 50 milliliters. To about right there. Next, measure the temperature by placing a thermometer in the vinegar and waiting 1 minute before you record the temperature. So we will set that in there. We will give it 1 full minute and then measure the temperature and make sure that we record it onto table 2. So we could probably zoom in here to see the temperature and if it might change from what it is currently. So what we're looking at is that red line, and we want to see where that line reaches. So the bigger line that we see there is 20 degrees Celsius. This just happens to be in Celsius. So we'll give it another few seconds just in case that temperature moves just ever so slightly. And it looks like the temperature is going to remain at that first short hash mark. And I believe we can check. I think the hash marks are every 1, 2, 3. Yeah. So that looks like it would be just 1 hash mark above the 20. So we would then record that onto our table 2 where it says vinegar, and we're going to be using the steel wool first, so we want to make sure we put it in that first blank. All right, so zooming out, step 2 mentions that we need to add the steel wool to the vinegar. So all we got to do is we need to place this steel wool into the vinegar. I'm going to momentarily move my thermometer out of the way. Now we could use the stir stick to kind of get this steel wool completely saturated, or you could use your hand because vinegar is not dangerous to touch, but we want to make sure that we soak up a lot of that vinegar into the steel wool. So we want to make sure we give it every opportunity to soak up as much of that vinegar as we can. And there we go. We are to record any changes or effects or indicators that we might see. So we look at this. Do you see any changes? Any noticeable changes from what you would expect? We are to wait 2 minutes for this reaction to continue to take place, and then we will observe it again and record the temperature. All right, let's first check and see if there are any changes or indications that a chemical reaction might have taken place. So you're doing your best to check for any changes from what you would expect or from what we saw originally. We can pull this out and check both sides here. And then we are to wrap the best we can the steel wool around our thermometer without applying any heat from our actual fingers. We will scroll up so that we can see the temperature yet again and watch to see if we see any changes over the course of the next minute. All right, so go ahead and take that temperature there, and we'll use that one for our recording. Again, we want to make sure that we pay attention to any changes that might have occurred. Do you happen to see any changes that might have occurred? If you do, you can write that onto table 1 under your observations. All right, so at this time, I'm going to rinse out my beaker and reset for the next combination of chemicals, and then we will repeat the process. All right, so I have it cleaned out. As we move on to our next step, we are going to be using a new liquid component and solid component combination. It's still going to be the vinegar, but this time we're going to be mixing it with baking soda. So we add our 50 milliliters of vinegar. We again want to measure the temperature, but we always have to give it 1 minute for the temperature change to take a proper reading. So while we're waiting on that 1 minute, I'll go ahead and zoom back into the thermometer so that you can take the temperature reading yourself. All right, so take a look at this. There's the 20-degree mark with that long line, and we can see that it looks like it's stopping there on that first hash mark yet again. All right, so we'll remove the thermometer just so it is out of the way. We are going to get 5 grams of baking soda. We're going to add it to the vinegar, stir it, and then we will measure the temperature again. Make sure you pay attention to any signs or indicators that a change has happened or that a chemical reaction has occurred. All right, so we're going to add the thermometer and wait for 2 minutes. Make sure you're paying attention to any reactions or changes that have happened and that you're recording those into your table 1 next to the baking soda and vinegar. We'll give it about 1 more minute here, and then we will take the official ending temperature. While we're waiting for this minute to finish up, let's take a look and see if we see any major changes from what we would expect. Still appears that the liquid is clear. We do see bubbles. And there is a little bit of a white powder down at the bottom. And then that's probably good on the temperature, so we'll go ahead and take a look at that. Sorry for my camera here. There we go. So we see the 20-degree line. And try to guess, it looks like it's about 3 hash marks below the 20-degree line. So we want to record that temperature next to the baking soda and vinegar. All right, so at this point, I'm going to clean up my area, and then we are going to do the next combination. This time we will not be using vinegar. All right, time for our third mix. This time we will be using 50 milliliters of water that we measured out in our graduated cylinder. Again, we need to measure the temperature. We put the thermometer in there and we will give it 1 minute. And we'll zoom in on that so that you can more accurately see what the temperature of the water is. And as we're finishing out these last few seconds, again, the 20-degree line is that longer line, and it looks like it's pretty much going to stay in that same location with that 1 hash mark above. So make sure that you record this temperature next to the water and calcium chloride on table 2 for starting temperature. So we'll move that out of the way. This time we will be taking the calcium chloride and measuring out 5 grams of it, stirring it around. However, calcium chloride is, I'll show you here, it comes in these like little, they're almost like little BBs or pellet type shapes. So it's going to take a little extra effort to get that to mix in. We'll actually probably have to crush it just a little bit to get some of those into more of a powder form. Try to stir it around really well. Try to get this to dissolve as much as possible. And we won't get all of it to dissolve, but we'll still be able to measure and determine if a reaction took place without all of it dissolving right away. So I'm going to go ahead and put the thermometer in there as I continue to crush this up. That way we can start our timer for 2 minutes. So the rest of that should dissolve and keep that temperature where it needs to be. So we'll once again look for any observations while we're doing the 2-minute wait. It does appear that the liquid is mostly clear. The little white dots is just the powder that hasn't yet dissolved. And then of course we need to take a look at the temperature. I think we have about 30 more seconds of this temperature before we can officially call it done. The longer line there is the 30-degree line. So we are currently 1 smaller hash mark below 30. And it doesn't appear to be moving anymore, so I might actually be cooling off at this point. So at its highest point, it looks like it was that 1 line below the 30-degree mark. So we just want to make sure that we take that temperature and we record it onto our table. All right, 3 down, 1 more to go. I'm going to go ahead and clean this up real quick, and then we will proceed with the final combination. All right, so we got it all cleaned up. Again, we are going to be using 50 milliliters of water. At this point, I don't think it will be any surprise as to what the beginning temperature is going to be. Hopefully you've noticed that there's actually a pattern to the starting temperatures. So once I get this put up, we'll go ahead and zoom in on the current temperature. It should be pretty close to what it should be from rinsing it, and the amount of time that we've already spent waiting for it should slowly be climbing back to the correct beginning temperature. So again, we have our 20-degree mark there. We'll give it about another 30 seconds, and then we'll call it the official starting temperature. About 20 more seconds. You know what? I wonder if that's in a warm spot. Oh, it's not too bad. I was worried that I was manipulating the temperature a little bit by having it in a spot on the table that was slightly warmer. All right, so we'll go ahead and call that. Again, like we've seen before, there's the 20-degree hash mark. and it's still relatively close to that first short hash mark. So make sure that you record that next to the ammonium chloride and water starting temperature. Again, we're going to be using 5 milligrams of, this time, ammonium chloride. Ammonium chloride looks a lot like salt. It is a type of salt, so that's one of the big reasons why. Of course, you wouldn't want to eat it, but the grains are much smaller. So we'll go ahead and add our 5 grams here. We want to make sure we give that a good stir so it dissolves. I'm going to go ahead and put the thermometer in so it can start reading the temperature as it continues to finish dissolving out. We want to pay attention to any observations or indicators that might be occurring at the moment. So we'll zoom in from the top and see if we see anything. So currently it looks like the liquid is mostly clear. We do see some of the powder still floating around in it, so it has not completely dissolved. So still not a lot in the way of color changes necessarily. You see that, you can see the thermometer through it. Now let's check out what the temperature is doing. We've done at least a minute in there. Scoot this back and zoom it in a little bit, maybe be a little easier to read that temperature. All right, so there's our 20-degree line. We'll give it about 1 more minute to see if it moves any more. All right, so I don't think it's going to change much more. There's the 20-degree line. It looks like it is about 3 lines below that. So we'll go ahead and record that onto our table 2 under the ending. Now, as we are finishing up and going to clean up, we want to make sure that on our table 2, we go ahead and take the difference. We're going to separate or subtract the 2 numbers. If the temperature went down, you should put a minus sign in front of your number. If the temperature increased and got warmer, you want to put a plus sign. Make sure you finish out any observations that you made. You're going to separate all of these reactions into one of 2 columns, either exothermic or endothermic, depending on how the energy was either released or absorbed. And then I give you just one of the equations. That happens to be the baking soda and vinegar, and it turns into a sodium bicarbonate, water, and carbon dioxide. You don't need to know that. But go through, just do the beginning part of balancing equation, and let me know if that equation seems to be balanced or not. You don't have to finish it out, but I would like you to at least tell me if the equation would need to be fixed or not. So that's the end of the lab. I apologize that you guys didn't get to do this in person, but at least you did get to experience it in some way.